I welcome you all to the Spark Research YouTube channel. This is Dr. Virchan, Assistant Professor in the Department of ECE, and here is another session of this particular course on electronics devices. And in this session, we are going to take the contents from the fifth unit. Primarily, we will focus on the design rule of the PCB design. So here is the contents. Here is the syllabus for the GATE exam. So you can check the syllabus. And here is the contents that we are going to take in this session. So primarily we are going to take the contents related to the design considerations. How will it affect the PCB design? Your environmental, then the cooling, packaging, and the layout of the PCB. And then we'll look into the design rules for digital, analog, and we'll look into the how to design the high frequency circuit, fast pulse circuit, and what are the problems, right? And lastly, we'll look how to design the microwave type of the circuits, and we'll have the some practice. Okay, so first question is that impact of the environment factors on the PCB design. So will it affect, like, what are the major points you have to consider, and why are we talking? Because whenever you are designing the PCB, like suppose you are designing the PCB, then it may be your PCB can be used either in Chennai, it can be used in Sikkim, it can be used in the Russia, it can be used in the Africa. So temperature will vary, the in a wide gap. So you have to design your PCB in such a manner so that it can continue to work in any temperature, not in any bit, but in all these temperatures. Means temperature variation may be, the minus 50 to plus 60, 80, maybe the 100 degrees Celsius, right? So you have to consider these. So this is the thermal or the temperature effect, right? Apart from that, the other, like moisture, humidity, sometime your electronics devices may fall down, and so the stress analysis or the vibration shock analysis, and then the contaminations, right? So all these environmental factors you have to consider while you are designing the PCB. So these are the very important considerations, right? So mitigation strategies may be the enclosures, material choices, plotting, design choices, testing. So you can the verify all these things, and then only you can have the final PCB product. So advanced cooling and the packaging strategies for high performance PCB. So whenever, like, we are designing the PCB, of course it will radiate the some heat, means the temperature will keep on rising. So once the temperature is keep on rising, then, like, suppose temperature may cross the threshold limit, then in that case your PCB may not work, right? So in order to keep on working, you are going to use some advanced cooling, and the packaging studies is, in order to avoid the heat, you can use the active fan or the heat sink some devices, so that the temperature may maintain in the proper range. So here is the layout. Already we have discussed the layout. So here, what is the target? Target is to design the PCB. So in order to ensure the good layout, layout means the proper structure made out, the circuit designer must provide the layout designer information on the following points: well drawn schematic and minimum number of crossovers, then the areas of the circuit incompatibility, those where isolation of one circuit from the others, and then the number and the position of the external connections to be used with the interconnection system. The board contacts should be designed numerically or alphabetically. Then the shield and the grounds to be clearly indicated, right? So that you can mount your components very easily. Here is the design checklist that you have to, the consider. So whether is it has the circuit been analyzed and divided into the logical paths for a smooth signal flow? Yes or no? Just you can check it. And are the components suitably distributed to give a uniform package density? Yes or no? Then placement of the component in such a way that results in short isolated criticals? Yes, no. Board size is minimum or not, routing is there or not, then the preferred conductor's width is correct or not, the preferred pad hole size is perfect or not, then heat sensitive components kept at the adequate distance or not. So you have to consider all these, right? Then the electrical considerations, this is one of the important parameters. So is there fully compatible between the circuit diagram and the layout? Has the circuit been divided into the subunits? Like subunits means suppose if the circuits are combination of analog and digital, then divide it. Okay. Mechanical considerations are also important. You can consider board sizes should be minimum, then it should be compatible with the manufacturing process, and mounting the hole size, drilling, everything should be compatible. The terminals and the control locations compatible with the total assembly. So all these. Okay. So here is the some design rules that we are going to use it for the analog type of the PCB. So system level zoning, so like suppose you have the analog devices, analog circuits, digital circuits, so you can first of all make analog signals, the analog region, digital region. So you can divide the, the circuits in the sub circuits, and then you can assemble analog circuits and then digital circuits, right? Power distribution network, you can put a common power distribution, from there only you can distribute the power. And then critical analog routing is also important, so minimum trace lengths and the differential pairs. Then the grounding strategies, you can keep a common ground for both analog and digital in order to avoid the repetition. And also you can like to eliminate the loops also, you can use it, but carefully, because both the grounds may not be same. So here is the some rules for the analog PCB. So component placements in today's world, people can easily assume they live in all digital world, yet analog signals are still found, right? More than 60% of present day electronic circuits. As for example, if you look into the nearby, except your mobile phone, laptops, most of the devices are the analog circuits, and that always contains the PCB, right? And so here component placement, signal conductor, supply ground, these are the major points, right? So where will you place the component? So component which needs to be accessed from the front panel must be placed exactly according to the requirements of the equipment's designer. Then the components for internal adjustment, such as potentiometer, trimmers, switches, should be arranged near the board is and placed in the proper direction for easy operations. Then the conductors, the width and length, and then everything like the signal conductor should be proper so that it can flow the currents. So in analog circuits, to variety of the task, including the input, reference level, feedback, outputs, all these matters. And the layout of the signal conductor: high frequency amplifier, multi-stage amplifier, high gain DC amplifier, differential amplifier. So and here is the supply and the ground conductor. So power supply lines should be the sufficient width to keep the resistance inductance to a low value. If it is if it do not have the proper width, then exactly your device will stop to work. For example, like resist. And also, what is this ground? So this is nothing, like this is the obvious alternate to the ground planes, where we are going to use the copper, and that may be the resistance of 0.0001, that is 0.025 mm copper, approximately 0.65 milliwatt per square inch, so that the solution is frequently adequate. Then design rule for your digital PCB. So here, like see, transmission line we are considering here. Transmission line made up of infinite long network of the capacitor and inductors. And to understand the concept of the transmission line, consider a long straight wire or trace with the return wire or the trace nearby. And so some capacitive coupling length between the returns, you can keep it. So point number one, that commonly use a lumped model of the wire, because the capacitor inductors are shown in the lumped components. In reality, the inductance and capacitance are spread continuously along the wires, right? In concept, the a long wire is infinitely and the figure only shows an infinitely a small part of the total length. So whatever we have shown, that is only a small part. So if you look into the front of this wire, there is input impedance with the mathematically calculated, and that input impedance will be Z naught is equal to X equal to square root of L by C, and LLC is the inductance and capacitance equivalent. Okay. Then the major problems. What are the major problems in the digital PCB design? So reflection is there, crosstalk is there, signal noise is there, interference, right? So these are the major problems. So reflections, the power may reflect back, crosstalk, the it may couple to the neighboring, then the signal noise, and then the interference due to the different sources of the electromagnetic wave. Then the for fast for high frequency design, like what is the meaning of the high frequency? So you can consider if the frequency is greater than 3 megahertz, you can consider as a high frequency signal. So about to 300 megahertz, right? And in digital circuit and in analog circuit, 100 megahertz is cut off for high frequency circuits. So for high frequency circuits, multiple problems will arise. So you have to design the circuits very carefully. The following guidelines for high, what are the major guidelines here? For bread power supply conductors, use broad power, right? It should not be thin. And then use a ground plate or very large ground surface for ground conductors. Provide a decoupling capacitor between the ground and the power supply. And for large size PCBs, dielectric losses play an important role. In such cases, use PCB with suitable high frequency directions. Then decide which parasitic element are more harmful and design the conductor layout accordingly. So these are the points that you have to consider. Similarly, for designing the fast pulse circuits, the fast pulse circuit means if your pulses may be the TR divided by 100 nanosecond, TR the rise time. If follow this one, then you can consider it as a fast pulse circuit. So the transmission or the interconnection is matched with both the source and the load. And if transmission line is not very long and a simple delay of approximately 5 nanosecond per meter is introduced. So in order to avoid the problems here, you can use a skin effect losses, increase PCB thickness, and keep line length small. Then the radiation losses, use a ground plate on one side of the PCB, decrease the PCB thickness and avoid the discontinuities. Run signal lines near the ground planes. Then the dielectric losses, use a good high frequency dielectric PCB laminate. Then the microwave type of the circuits. So microwave type of the circuits that may contains the some wave that may come under the microwave. So examples may be the type of the antennas you are going to use, which will emit or or which will receive the signals here. Maybe the micro strip type of the antennas, right? So minimum trace lengths or the short connection to the ground via ground only, and place the ground wire directly at the pad, and use shielded enclosure for insulation isolation. Okay. Then the conductor geometry and impedance. So for microstrip or for a strip line, these points are important. Exactly, these are the waves which may reflect back. So VSWR you can calculate using the equation like VW T is equal to T naught. Here you can check. So VSWR you can find out using a 1 plus rho divided by 1 minus rho. So rho is the tau, that is reflection coefficient, maximum value of the voltage along the line, and divided by the minimum value of the voltage along the line. So you can also calculate VSWR using this, right? So strip line and the micro strip line. So today's high performance PCB traces are the manufactured as transmission line. In principle, several types of the planar transmission line can be fabricated. Okay. So a strip line is basically a sandwich of the two PCBs, one double side and one maybe the single side with the transmission line on one side and a ground plane on the other, and one single-sided PCB with ground plane over its entire area. This is illustrated here. So the mode of the propagation is TEM, transverse electromagnetic wave. In this mode, the electric and magnetic fields are perpendicular to the direction of the wave propagation. Suppose wave is traveling in this direction, then the both of them will be the perpendicular electric field and magnetic field. Then the microstrip line. So is this microstrip line is nothing but a double side PCB with the conductor line on one side and the ground plane on the other side. Okay, so this is showing here. So dielectric is usually made of the glass reinforced epoxy such as G10 or FR4. These are the materials that are being used to design the PCB related to the microstrip. So the modes of the propagation in the microstrip line is not strictly TEM but quasi TEM. Of course, TEM is the not possible, but quasi is okay. This is because of the discontinuity of the electric and absence of the symmetry of the ground plane with respect to the line conductor. Okay, so thank you, design. So play today, stay healthy tomorrow, and learn for a lifetime.